Second test, that is block rotor test. Here as I completely blocked the rotor of the single phase induction motor. Here the small changes I made. The changes happens that in the voltmeter, instead of 300 volts I am choosing that 150 volts, because the range of voltage is very less here in the short circuit test. Here again I chosen the ammeters around 15 amperes range meter, because I need to get the 10.5 amperes rating, that is a short circuit current I need to apply. Hence more than 10 amperes, that is around 15 amperes I taken for this ammeter. And this is a UPF wattmeter, unity power factor wattmeter. Nothing will be indicated on the UPF wattmeter as in terms of power factor. So this is unity power factor wattmeter in this one, and this voltage range also I have chosen that is 150 volts. Previously it is 300, now it is 115. Why? Because my voltmeter range I chosen as 150, hence this range also 150. So in this case we must remember that in blocker rotor test or short circuit test we need to apply the rated current. The rated current is a 10.5 amperes. Now I am applying that current in this ammeter by varying the variac slowly. So I am regulating the variac. I am applying 10.5 amperes. So this is a short circuit current. So this is my short circuit current now. So during this short circuit current, so 10.5 I applied here. So this I am telling as short circuit current ISC, and this I am saying as voltage VSC. This is also short circuit voltage. This is voltage absorbed under short circuit, hence I am calling it as a short circuit voltage. So this is 42 volts around, and similarly you can observe the wattmeter reading. The wattmeter reading here, it is actually 0, 100, 200 range is there. So it is more than 100 now. So you can say each portion, each partition will be having around 20. So that it's showing 140 watts. So 140 watts it's showing by the wattmeter. I am writing 140 watts multiplied by its multiplication factor will give the total short circuit power. Similarly, current, if you observe the current, that current is 10.5 amperes. This is applied current, and here is the voltage is 42 volts. This is short circuit voltage. So by conducting this test, we observed the short circuit voltage, short circuit current, and short circuit power. Similarly, in the previous test we got open circuit voltage V0, open circuit current I0, open circuit power W0. By knowing all these values, this short circuit voltage is PSC, short circuit current is ISC, short circuit power is WSC. By knowing all these 6 parameters, by doing some analysis for the equivalent circuit, you can measure all the values which is required for the equivalent circuit, which is shown previously. So you can replace those values in the circuit, the theoretical values with the practical values. You can get complete equivalent circuit of the single phase induction motor. Now you need to observe one thing, that while conducting this short circuit test, the rotor of the induction motor is now completely blocked by means of the external weights. I added the external weights in order to block the rotor. Now it is at a 0 speed position, it is not at all running. So means that the rotor is short circuited. So once rotor is short circuited, all the values that we measured is you call as a short circuit voltage, short circuit current, and short circuit power. Thank you, and in the next lecture I will explain how to calculate all these things.